So a profit function is given as p of x equals 100x minus x squared, where the output is measured in hundreds of dollars. And at what production level is the profit 0? Basically, we're going to take our model here and set it equal to 0. This one, to solve, I think the easiest way is to factor out an x. So we get x times 100 minus x. And then we can actually kind of see the x values that make it 0. If x is 0 or if x is 100 are our two profit levels. And this is cars. So make sure you remember your labels. Now, how many units must be produced to yield the maximum profit? Well, that's basically the vertex of this quadratic. So to find the vertex algebraically, it's x equals minus b over 2a. In this case, b is 100, so negative 100. A is this negative 1 here, so we got to, you can imagine the 1 on that. A is always multiplied by the x squared term. Don't let the fact that it's out of order confuse you. So 2 times negative 1. So 50 cars is the production level. That yields the maximum. And that means the maximum profit is P of 50, which is 100 times 50 minus 50, squared. So we're going to have 5,000 minus 2,500, so 2,500. Now careful here. Remember, profit was measured in hundreds of dollars. So the actual max profit, we have to put on the 2 zeros for the hundreds. $250,000 is the maximum profit based off of this model. That's also going to be important when we go into part D. How many units need to be sold for a profit of 200,000? When we set up our equation, 100x minus x squared equals, we're not going to set it equal to 200,000. We're just going to set it equal to 2,000, and this will be the equation we solve. One way of solving this is we can get it all equal to 0. So 0 equals x squared minus 100x plus 2,000. And then this can be used in the quadratic formula, and that'll work out just fine. I want to show you how to do this with a calculator for another option. And both of them are fine for the quiz and the exam, unless you're told to do it algebraically. Algebraically would mean use the quadratic formula. So what I'm going to do is I'm going to put each of these in as a graph. So the 100x minus x squared, and then the 2,000. I'm going to be looking for where they intersect. But I'm not going to see much if I don't extend my window. Remember, we had zeros at 0 and 100. So let's let our x's go from 0 to 100. And then our y max, we needed at least 2,000. Well, we had a 2,500 was our max. So we should be able to see this pretty well. There's our quadratic. There's our 2,000. And here's our two values. And we want both of them. So we're going to do second calculate intersect. We'll go over by this intersection point. Enter, enter, enter. 27, can't quite see it because of the light, 27.63. So because we're talking about cars, let's just do a whole car. So, and you could round that up or down. So 27 cars, or let's get this other one. We do the same steps. Second calculate intersect. We'll trace over to that one. Enter, 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 and 72 cars. We rounded off because they're cars. If you use decimals on this, I think that would be okay in the context in what we're trying to do in this problem.